Welcome to part 1 of the terrain tutorial series. This is part of the Magic Market series in which we were responsible for creating all of the environment assets. So in this tutorial we're going to be creating a terrain from scratch using Houdini. So that means creating the height field and then generating various features on our terrain based on the type of terrain that we're going for. We're then going to generate masks based on those features and use them to drive our textures. I'm also going to go over some basic instancing in Solaris so that you can learn how to populate your terrain with various rock and foliage assets. And just a disclaimer about this tutorial, this isn't intended to be followed along exactly. We're not going for a particular end result. I'm just trying to show you how you would go about creating a terrain. So once again, this is more of how you would go about doing it yourself. So let's get into it. So the idea for the Magic Market terrain, so if this is just an aerial view, if we're looking down, we would have the market situated somewhere like this. And this over here is, the main area. From there, we would have the camera view. So the camera view would look something like that. If this is the camera down here, right? So that's the camera view pointing this way. Now on the sides, there would be a sort of cliff face that wraps around and behind the market. This area behind the market would be lower and it would kind of be a sort of rock pool. So there'd be a waterfall over here and that would feed into this rock pool area. Over towards the side, there would just be foliage. So all of this would be foliage. And the market exists in this sort of clearing area. So you can see that this area in between the foliage and the cliff face acts as a sort of clearing. So knowing this helped a lot because we knew that all of this would be cliffs. All of this over here towards the back would sort of be lower. And there would also be this walkway in front of the market. So when creating a terrain, I would suggest doing something similar to this, just getting a very rough idea of how you would like your terrain to be set out and where you would like your camera to be focused. By doing this, we knew that we could limit the amount of terrain that's seen and really focus mainly on this central area around the market. So I'm going to show you how I created this terrain. You can do your own sort of terrain, but I'm going to show you how I created this sort of shaping. Alright, so in Houdini, let's begin by dropping a geometry node. Inside of this geometry node, we can drop down a height field. And this is generally how you would start a terrain. Now, by default, it's 1000 meters by 1000 meters. So we're going to drop this just to 150 by 150. Because we've shrunk it down, we'd also like to change our grid spacing because this is basically the resolution. We're saying make 2 by 2 meter blocks, right, all over our terrain. So we can drop this to something like 0.25 and that should be good. So now we have a canvas. We have a canvas to work on. So I know the shape of the terrain that I'd like. It was basically what I drew out earlier. Now I know my drawings leave a lot to the imagination, but I have a fair idea of what I'd like. So let me drop down a draw curve. With this draw curve, you can actually start drawing out the shape of your terrain. This is quite a useful tool for doing so. All you have to do is change the projection to the ZX plane. So now with your height field displayed, but your draw curve selected, switch on your transform handle and you can begin drawing out a shape. So what I'm going to do is I'm going to draw out the general shape of my terrain. So firstly, I'm going to block out this side over here. Now I know that it would come around like this and the rocks would go in over here. This might be the rock pool area. Then it would come around. The market would be over here, and then it would go this way, right? Something like that. This doesn't have to be perfect. This is just the general shape of your terrain, and you can make lots of changes to it afterwards, but for now, I'm going to be doing something like this. I'm also going to draw the other side, so over here, just something like that. Okay, so now I have an idea of how my terrain is going to look. With this draw curve, I can now run a fuse node on it. That will close it up. So we can just increase the snap distance to quite a high value and then do a polyfill. We're just going to polyfill as a single polygon and then run it through a remesh. And by default, your target size is 0.2. Remember, we're working at a big scale. So this is going to result in a huge number of points. Just switch the target size to about 1.5. And now all we have to do is just poly extrude it. Let's poly extrude this up. So we're not going to use distance because we're not confident in the orientation of our polygons. If one side is reversed, then they would both be poly-extruded in different directions. So to avoid that, all you have to do is use transform extruded front and switch it to global. And then on the translate for Y, just set this to about 2.5, maybe a bit higher. We can do 3.5. And this is going to be the height of our cliffs. So they're going to be quite low. That's not going to be ridiculously high, but that should be good. So we're also going to just output back. And if your polygons are blue, as mine are, you can just use a reverse node. That will flip the geometry the correct way around. So now that we have this, I'm just going to use a bit of a mountain node, increasing the height to quite a high value and the element size to a higher value as well. Something like that. Now we can use this height field that we have over here and use a height field project with it. So you can also type HF project. That's a quick way of searching for height field tools. Just use HF. So into first input, you'll use your height field. Into second input, you'll take your geometry and you end up with this. So, not amazing, but it's something to work with. And I'd actually like to redraw this second curve. So you can go over to stroke and remove the second curve, and I'll just redraw that one. So just redrawing this second curve to something a bit better. And yeah, that should be fine. So I'm just going to increase the element size over here, just to something like that. So yeah, just very basic shaping. So the next thing that I'm going to do over here is just drop down a height field paint. So you can type HF paint, and this allows you to paint masks onto your terrain. So you have to go over to your transform handle, and you can start drawing on your terrain. Now I'm going to drop the opacity because I want to layer this. You can start out by drawing in this area over here, and then bring it out slightly over here. So the reason we're doing that is because we can now use a height field remap. So HF remap. And to use the mask that we just created, we plug the paint into the second input as well. We then say compute range. We can increase the output min slightly, and then decrease the output min, just about minus 1.4. What that does is it pushes that area down. We have the basic shape of our terrain. We can now go ahead and drop down a resample. So that's a height field resample. And we're going to use this because now that we have our general shape, we need to start adding more detail to this. But to add more detail, we need a height field that can actually handle more detail. This is a very low resolution height field, and so we need this to be a higher resolution. We can switch our resolution scale to about 4. That will just multiply the resolution by 4. So you'll notice that we have very smooth edges over here on our terrain. One thing that we can do is do an HF mask by feature and just mask these very harsh edges. So we're going to go over here and mask by slope. So the minimum slope angle will increase to about 50 and the max will be about 100. As you can see, that selects only those edges for us. So now we only have those faces selected. What we can do is do an HF noise. So that's a height field noise. And for this noise, we need to plug in our mask once again. So just plug this into second input as well. Now this noise amplitude and element size is massive at the moment. So drop the amplitude to 5 and the element size to 5. And we can increase these values, 10 and 10. And what I'm noticing is that it's very sharp. So we can do an HF mask blur and just plug it into the mask input. So firstly, we're going to change this to an expand and then decrease the radius on this to about 3.2. Then we can do another blur. So that is a height field mask blur. This one, we'll just do a regular blur with a radius of about 4. Now when we use our noise, it just adds noise in these areas. Once we have that, we can just do a mask clear. So that is height field mask clear. And that will remove our mask. And you'll notice that there's no detail on the actual faces of this geometry. And the reason is because height field is sort of limited in that regard, in that you can't really have detail on these faces because these areas don't actually have resolution. So you can't really add detail to them. But we'll fix that at a later point. Let's continue for now. We're now going to use a height field erode and just plug it in right after our mask clear. Now you'll notice that it makes the terrain brown, but how this works is that it requires time to run. So what we're going to do is firstly decrease the removal rate to about 0.05, that would be under advanced. We're also going to change the density of our precipitation to 0.02. What this does is it ensures that our hydro erosion, so it basically simulates rain over time, doesn't remove too much of our height field's shape, right? Because you can set this extremely high, and when you run this, it will remove most of the detail of your terrain. We're going to go down to debris flow and just tell it to post smooth. We'll increase our spread iterations to 15. Now, all of these are just ways of controlling the erosion of your terrain. So by decreasing the density of precipitation, you're decreasing how much rain there is. By increasing spread iterations, you're ending up with less cutting into the terrain and more of an even spread of debris. So we can just run this for a little while. And what we'll do is tell it to freeze frame at frame 20. So right at the top, just toggle on freeze at frame. And we'll leave it at 20. So it will now run and we'll see what we end up with. When it's finished running, what you might notice is that it looks as if it's generated dunes, right? You have these areas where it slopes. And the reason for that is the thermal erosion is actually quite high. So to correct this, you can go over to main, and under thermal erosion, go to erodibility and drop it to 0.1. That will more or less remove the thermal erosion, and that will help it a lot. You can let it run again, so just reset and reset simulation at the top and let it run again. Great, so now that we have that, we can go ahead and actually mask by an object, because you'll notice that this area that we want to be a path has now generated some detail to it. So to remove that, all we have to do is do HF mask by object. We'll grab our terrain into first input and go up to the mountain node and plug that into second input, right? So now we want to invert this. So all we have to do is on this height field mask by object, say invert mask. Do a bit of a blur. So we'll do 3.6. That looks good. And then what we can do is a blur HF. So height field blur. We're going to blur by mask. So that means we have to take this mask by object and put it into second input. And that will smooth out this area for us. So that smoothing looks a bit hectic. So we can drop the radius just to something like that. So we can now do a mask clear and take a look at our new terrain. So that's how our terrain's looking right now, and that's pretty cool. So now that we have the basic shapes in place, we can decide to actually cut out an area and work on that separately. So let's do a crop. So that is height field crop. Plug that into first input. We're going to crop a 60 by 60 meter area, and you can also move this around. We just want this area right here. So this is our main area that we want to focus on. So this is basically the idea I was trying to draw out, is that this area over here drops down below the area of the rest of the path, and then you have this sort of cliff face around the outside. Now, it would be quite cool to add a waterfall, and it would be even cooler if we could somehow only erode away where the waterfall is, right? As if water were flowing in that area. And we can actually fake that sort of erosion if we use an erode node and then localize the area for erosion. So let's drop an erode over here. So HF erode. Now we don't want to just run it as is. What we're going to do is plug our crop in as a mask. Now that's not so that we can actually use it as a mask, but what you'll notice is if you plug this in and then switch mask on, you can actually add a mask. If this isn't connected, that option is grayed out, as you can see here. So we plug that in, and that allows us to do some erosion. So we're not going to be doing any thermal erosion, so we can switch that to 0. We are going to be doing hydro erosion. So go over to your advanced settings, and the first thing that we're going to do is reduce the debris flow. So the max height we're going to drop to 0. We don't want debris, we just want erosion in a particular area. So we're also going to post smooth and increase the quantization of the water flow. So just doubling it like that. Now we have precipitation, which is one important factor. That is rain. So this is our rain amount. So we're going to come back to precipitation. Let's go over to main, and under erodibility, let's choose mask on. We can then click on this mask paint over here. And what you'll notice is that it adds a mask paint and this over here, which is a height field copy layer. And then this over here allows you to paint. So you can select your mask paint, and let's just paint an area where we want some erosion. So I'm going to select this entire area at the base of our rock pool and up the cliff face, and then back and around. So something just like that. So with our hydro erodibility mask over here, we can go over to advanced, and under our precipitation, we'll also add a mask here. Now we're actually going to use the same mask, so we're going to call it Hydro Erodibility Mask, and so you can just select it from the dropdown, Hydro Erodibility Mask. Now we're going to go down to our debris flow and increase the spread iterations. We're also going to expose these raindrop settings and increase the blur radius, so 0.5 and an expand radius of 0.5. This is basically just saying create bigger raindrops. So what that will do is result in much larger incisions into our terrain. Right, so as you can see, that's eroding away quite nicely. Right, so it looks pretty good. We have that area over there, and that can be our waterfall area, and it's also eroded away somewhat of a rock pool. And so you can let that run once again for 20 frames by freezing at frame 20. So great, we have this terrain, and it's starting to take shape. The next thing we're going to do is resample this. So drop down an HF resample. We're going to increase this, so the resolution scale we can increase to 2. And now what we can do is blur this area. So let's drop down an HF blur, and we'll want to blur by a mask. So let's plug the height field resample into second input, and once again, it's very easy now to just click over here and add a mask paint. The area that we want to blur is this waterfall area to remove these sharp edges. So we can then decrease the value on this blur, decreasing that radius, just so that it removes the sharp edges, just something like that. Now, the only other thing that we really want to do in terms of shaping is some sort of cliff face. So to do that, we're going to drop down a height field terrace. Now, the cool thing about the terrace is that it's based on the features of the terrain. So over here, you drop down your terrace, and then you tell it to compute the range. This computes the height of your terrain, and then you can work from there. So the max step size we're going to decrease quite significantly because we want much finer terracing. We're also going to decrease the max height, and let's do a max height of 4. So as you can see, it keeps the cliff tops but adds this sort of terracing. And we don't want our terracing going so low because as you can see, it's affecting this area over here. So we can push up our min height as well. We can maybe drop this a bit, so we'll do minus 0.5, and yeah, I quite like the way that that looks. Now we can also go down to undulations and use a standard. Once again, this element size is huge, so we'll drop this to about 1, and then drop our amplitude as well, 0.5. What this does is it adds a bit of randomization to our terracing. So we can mess around with this, and we'll use a fractal of standard FBM. If you've watched our rock tutorial series, you'll know why this is such a good noise to use for rocks, and we can play around with this. So we will limit the area for terracing because we don't want such hectic terracing right in our path. So to adjust that, what we're going to do is just use another mask. So just click over here to add a mask paint, and once again, we'll just paint an area where we want our terracing. Cool, so we have successfully limited the area where our terracing is occurring, and that gives us some interesting shapes in our terrain. We can now drop a height field mask clear, just to remove that mask that we used. So from here, you can actually just output your terrain. You can do an HF convert, that is convert height field, and you'll end up with this. Now, there's quite a lot of points involved in something like this, and what you could do is you could bake out a displacement map. Now, there are multiple ways of doing it. One of the ways we go over in the other part of this tutorial series, which is the procedural rocks tutorial series. So if you want to check that out, you can see how to bake out displacements from there. Alternatively, you can rely on other textures to add detail to this. Now, what we're going to be doing is actually separating these areas into cliff areas and the normal path area. The reason we want to do that is so that we can target these cliff faces and apply a different material to them. So how do we go about doing that? Well, before we convert our height field, we would need to single that out. So to single out the cliff faces, we use a mask by feature. Now, not the regular mask by feature, but the height field mask by feature. So with this mask by feature, by default, it will actually pretty much select what we want. It's using a minimum and maximum slope angle. All we have to do is increase the minimum and increase the maximum. So you can choose what sort of masking you want. Perhaps you even want to go lower with minimum slope angle. And you can do something like that and it'll pick up edges over here, which might be kind of cool. So let's do that. So now that you have that, it is currently just called mask. If you take a look, you'll see that you have all of these over here. You have cliffs, mesa, mask, water, debris, height, sediment, bedrock. Now, there is this cliffs over here, but it's not what we want. It's the auto-generated one, which doesn't exactly pick up the field that we want. What we do want to do is turn our mask into a layer. So we want to turn it into something called cliff or rock face or something like that. So, let's do that. So all we need to do is just do a height field copy layer. Height field copy layer. Right over here. And all we need to do is set it from mask to rocks. So we can call it rock or rock face, something like that. And if we take a look over here, you will see that we now have rock face. So our mask has now been converted to a rock face. Cool thing is, once we convert this, it may appear that we've lost all of our layers. But if we actually just do a color node and we ramp by attribute and put rock face in here, so rock underscore face, you'll notice that we still have the rock faces as an attribute, which is pretty cool. So once we have converted our height field, we end up with a lot of geometry. I mentioned this earlier, we do have a lot of geometry. There are a few ways we can limit the geometry that we have here. What we can do is a resample, so that's a height field resample, because this runs a lot faster than resampling the actual geometry. So we specify exact resolution, so we can actually see what the voxel size was. We can take a look over here and it says voxels 3.7 million, voxel size 0.03. Now voxels end up equating to points more or less. So a voxel size of 0.03 is actually what this grid spacing is. So we can increase it to 0.05. And if we take a look now, we have 1.4 million voxels. And we can increase this to 0.1. As you can see, the resolution of our terrain is dropping. So now we only have 300,000 points. And that might be what you're looking for. Just a terrain that looks like this. So that's not bad. And we still maintained all of our attributes. The only thing that we would really need if we wanted to render this were UVs. So how would we go about doing that? So the easiest way to actually add UVs to this is to simply drop a UV flatten. Because if we actually take a look at these UVs as they stand, you'll notice that there is some significant stretching in certain areas. And this is just because of the way that the UV project works. The way that these UVs are calculated is, I assume, the same way, because if you take a look at what the UV project generates, when you let it initialize the best plane, it gives you some very similar results. So the best fix that I found for this is to use a UV flatten, switching it to be angle based. So we'll do that instead. So let's do an angle based UV flatten. So if we take a look at what those UVs look like, you'll notice that that stretching has been largely fixed. So cool. Once we have this, our terrain is in a decent place. So we can file cache this out. But one thing that I'm going to do just before I do that is actually an extrude volume. This is something that I noticed when I rendered in Karma. When you activate displacement on a flat plane like this, you end up with some artifacts where you can almost see through it. And I found that it gets corrected if you just drop an extrude volume. So you can just extrude volume to the lowest depth that you can go. So we'll do minus 0.1 and that'll just give this thickness. Once you have that, now you can file cache this out. So we can just call this terrain.bgeo.sc and we'll only save the current frame, save to disk, and load from disk. Cool. So we have our terrain and we can just drop a null and call this terrain out. So that's it for this part. And in the next part, we'll be going over some of the texturing stuff. I'm going to show you how cop nets work, so you can create your own textures in there and apply it to your terrain. And then after that, we'll be taking this into Solaris and really building up our terrain from there. So thanks for watching. I'll see you next time. Bye.